Alex received a first degree in computer science from ATEI in Thessalonica in Greece, in 2016. But since then, he's done a PhD in 5G Internet of Things, IoT, from the University of Bristol in the UK. And he's currently working as a solutions architect for the Smart Internet Lab at the University of Bristol. And the topic he's talking about today is building the future shipping industry network and applications. Okay, over to you.
Thanks Mike. Thank you for the introduction. Very nice to present here today. So without further ado, I'll start presenting the project behind this presentation and what am I going to show you today. So the project is 5G Logistics. It's funded by the DCMS, and it's comprised of a lot of industry partners. You can see here down the screen, as well as local authorities and the University of Bristol. So what we are building in this project is, if you like, future applications for logistics. However, we are conducting research over private 5G networks and applications on top of it. Especially our focus is on ports, and particularly on future ports, smart ports, and the idea of free ports, as has been looked up from the government recently in terms of creating new free ports in the UK. So what we are doing in this project is trying to focus on free ports, but with a more automated flavor in terms of logistics, and of course introducing 5G. So before I get into all that stuff, I'd like to introduce a little bit the story of ports and how they have been improving and changing over the years. So we are kind of at the moment into the stage where we have seen smart ports around the world, but we have not been able to understand how exactly 5G networks go into that, and how AI and IoT. So this project is kind of trying to bring everything together. The motivation for the ports and the industrialization has been always cost, efficiency, and this is something that it is supposed to happen with artificial intelligence, 5G, and these new smart technologies. So this is what we have been building for the last 12 months, and now we are starting to getting it out into production. In the Bristol port, we're deploying the private 5G network together with our industrial partners, and we're trying to share the advantages of the collaboration between AI and 5G. Usually the reaction we get when we are talking about these technologies is looking like this. It's not easy to share what we are doing in terms of very technical developments and how those benefits are shared. So before we go to the benefits, let's look at why AI and what is missing from ports and logistics, and how 5G is able to complement that. So within logistics, we have started many years ago by logging into textbooks. Then we started using systems online, distributed systems, and so on and so forth, to kind of improve the transactions and how we deal with logistics. However, it is a very complex area, and it's human-based. According to our research through the last 12 months, there are systems that are based on step-by-step human interventions such as logging trucks and checking cargo and so on and so forth. So there is the sense that it's time to start utilizing AI in production and actuating on top of the decision making of AI. So we think AI is a winner, and we're trying to enable it for ports and logistics through 5G. So how we want to do it? We need to look at why 5G and what is missing at the moment, and what 5G enables us to do. So this is the Bristol port map, and as you can see, it's quite a complex area with a lot of industries, a lot of buildings, and thousands of shipments coming in and out. So if we wanted to connect different use cases, for example, what we're doing in this project is we're trying to integrate drones as security system. We're trying to connect the containers connected on the trucks and monitor the goods when they come in, when they come out, the exact location, and so on and so forth. And in order to do that, we first investigated how this can happen with current networks and how we could connect our sensors, our systems. And what we have been looking at is current public networks and the connectivity issues, the latency issues, and of course the security issues that we would have to face with. And within this project, we have been working primarily with private 5G networks, where these issues have been removed as the control of the network has been of the port. But for this project, it was in control of the use case developments, which one of those is the 5G free port use case. So if we look at how the platforms would look like in terms of machine learning and Internet of Things or any kind of data points, we have a twofold approach in terms of collecting data, training and serving our models, and then making decisions on top of using them. So there is an infrastructure there that needs to be managed, and it's a complicated question, and it's difficult to manage because you might have thousands of models, a lot of data streams, different outputs, and there is of course bandwidth and computing to provide. It's very difficult to scale on top of different endpoints, different platforms, and also the security is complex because the machine learning models are always open to adversarial attacks, and in this kind of applications such as drones and sensors, it's extremely important to look at those. So in terms of real-time AI applications, we have gathered together an architecture to see how we could make things work. So we have seen within a private 5G network how we can utilize the multi-access computing, how we can deploy machine learning platforms, IoT platforms, create an enrichment mechanism of fusing data sets. For example, if we have RFID and IoT, how we fuse everything together to provide ready-to-use data sets for machine learning. And this is what we have created, the link between machine learning models for training and for serving as well. So some of our goals has been to deploy a private 5G network to the Bristol port, identify the key challenges of free ports and logistics, to develop the technology required to tackle these challenges on top of the private 5G network. We wanted to transform Bristol port to a smart free port in terms of integrity, future technologies, and try to see how today's free port would look like compared to the past. We want to demonstrate the technology and benefits, and hopefully we'll make Bristol a leader in free ports and smart end-to-end logistics. We have been looking at ports across the world to compare to. So we have seen the port of Shanghai, Singapore, Rotterdam, Jebel Ali, and the port of LA. Some of these are free ports, but all of them are utilizing some kind of intelligence and AI for either processing of goods or movements and the other ones. So we use these ports as benchmarks to compare our technology and try to compete with what they have done. So what are the benefits of, of the project, and specifically of the Freeport use case development? So firstly, the damage and mishandling of logistics is indeed an issue, and it's quite a big one. Looking at data, there is as much as 11% of cargo damaged and delivered into the final endpoints without really without of ensuring a lot of quality. So this is a huge number, and it is indeed a problem where many times it goes to costs to the logistics companies, so their costs are increasing. So what we can do here is we can monitor in real time the condition of within the truck by dealing with the Faraday cage of containers and connected to 5G networks. We can do that in milliseconds and provide some better monitoring on what is happening during transport. Also, there is theft and loss of goods, which is also an issue during transport. There is a yearly loss of 250 million pounds just in the UK of lost cargo, of lost packages or pallets. So what a 5G network can do here is try to classify these scenarios and try to predict them, and in real time provide feedback to the driver or to the logistics company. And particularly in terms of Freeport integrity, we want to create platforms that are able to monitor in real time all the data coming in and out of ports, what that cargo is holding, and if it has been tampered or changed during the storage or the transport period. Finally, in terms of smart logistics, we are trying to create an API, a third-party API of everything that we're developing to integrate systems such existing today, such as Destinate and other systems that exist for logistics and ports. We want to utilize the real-time capabilities of a 5G network and the sensors that we are deploying in order to improve the transactions, improve delays, and study together with the industry how we can actually move forward to automation and with utilizing Internet of Things, artificial intelligence, and so on and so forth. So I'll leave it on the technical side. This is kind of what what we have developed and we are going to test in the beginning of 2022. So as you can see here, we have gone into the containers of the port. We have deployed RFID for asset tracking to a good level, and sensors for condition tracking and acceleration in order to pass that data to the 5G network, and together with the radio to try and create a better location tracking versus GPS, for example. So we have deployed our own 5G router within the container. We have connected that out of the Faraday cage to the private 5G network, multi-access computing. And from there, we are essentially creating additional data sets, fused data sets for different regions for analytics in terms of research, for providing data to the port or other insurance or other logistics companies. So an example of what we are going to demonstrate is this. So we will have a container holding different kinds of products, where in each so we will essentially slice the container virtually, and we will provide monitoring in each area, as you can see here, in the area A, B, C, D, for example, where we have RFID telling us what products are there, and sensors telling us in what condition they are, and where they're going, and where exactly they are. So we're going to demonstrate the full project in March 2022. And what we are trying to do is to create a generic model that will integrate with ports, custom systems, and other industries that are looking at optimization, such as optimizing delays, security, and so on and so forth. So we have a demonstration coming up in March 2022, and our current analysis and data is looking pretty good. So we are hoping to demonstrate something pretty advanced and showcase our the 5G logistics project achievements. Thank you so much. More information can be found in the link regarding the project and what particularly we are developing. Any questions? I'm happy to answer.
Thank you, Alex. So I had some questions generated. It seems that you're adding services on top of existing IoT devices. Is that correct? So do people have to? Is there a certain specification for the IoT device that the port needs to use?
So we are we're building the hardware as well. We're working with on the end-to-end IoT network. So the sensors we are putting are monitoring acceleration, movements, temperature, humidity, dew point, atmospheric pressure. So we have been spending a little bit of time with talking to the logistics industry and so on and so forth, because before we go to the deployment, and we have figured out that these are the sensors that it will make more sense to deploy and
Okay, but will those sensors eventually be available off the shelf, or you say you're designing the hardware, but will they be available off the shelf eventually?
Well, I mean, there are plenty of sensors available on the shelf. So one of the main goals of this project is to demonstrate that heterogeneity. So either the sensors that we are putting or other sensors will work with 5G. So it's
okay. So a couple of other questions come in. No, thanks, Alex. So Samir has asked a question, an interesting one. How do you deal with data quality and data management?
Well, it depends on is the question regarding the machine learning training and deployment, or it depends on the sensor itself. So what we are doing is we are controlling the end-to-end infrastructure, let's say. So we have control of the IoT platform, of the machine learning platform, of the sensors. So if there is anything out of the ordinary, for example, in the sensor network or on the platforms that we are hosting in the multi-access computing, we are able to get status updates, like alerts, for example, and deal with any issues, for example.
Okay. A question also from Amanda. How does this link with IMO and cybersecurity issues?
Well,
E.g. risk management.
I think security has been a big question for us regarding the end-to-end from the sensor data to the machine learning to the actuation, and I'm afraid this is something that we will have to investigate in the future.
Okay, and I think just one last question again from Samir. How do you deal with cargoes that aren't equipped with sensors? Do you get a sort of mix of some with sensors, some without sensors?
Well, at the moment, this is an 18-month project where we are creating a proof of concept. So
Okay.
the cargoes that are not equipped, they're not monitored.
Okay. Okay. So you only monitor those. Okay. Brilliant. I think that comes to the end of our 20 minutes. So thank you very much, Alex. And we've recorded that for availability afterwards as well for attendees. So if you want to see that afterwards, it will be available.